Hello and welcome while I get set up. I'm sorry I was not here last Thursday. Not that many people noticed, but that's fine. Last week I was a little sick and could not appear, which is all well and good. Sometimes we need a day. Mercifully, we are given 80 hours a year to do with as we will in our workplaces, generally speaking. So all is well. Today is part 5 of our fraction trek, which is multiplying fractions. We have finally made it. Now, we have gone through, we have found greatest common factors, we have simplified fractions, we have, that is to reduce fractions. Now we are getting into the multiplying of fractions. So what does multiplying actually do? So a nice illustration here of what I have found, or what is provided to me here. So we have this block, and there are 3 sections of it. And 2 of the 3 sections are shaded, representing the fraction 2/3. Now, the same area, or the same rectangle, mind you, we have 5 pieces, if I can cut it equally, and 4 of these pieces are shaded in. Better? Worse? I think we just need, funny enough, a little less light. I think we'll do that just fine. Alrighty. Oh man, me and this camera will never get along. I don't know why. It'll be fine, but until then, I'm sorry you must suffer with me. So we have 2 boxes. One is 2/3 of it shaded, one is 4/5. Now, if you were to multiply 2/3 by 4/5, what that does to the same size box is you have your 2/3 and you have your 5/5, 4/5. And you color in your 2/3. And then you color in your 4/5. So what that leaves you here is this overlap I can use another color. Because we are in the Technicolor age, we are left with this overlap, which is 1, 2, 3, 4, 5, 6, 7, 8 out of the now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 units. Now, multiplying fractions is you can multiply straight across. So 2 times 4 is 8, 3 times 5 is 15. This is indeed what we are provided. I am excited about it too. It's really cool. So cool. So if you're provided with another example of, well, let's say 5/8 times 7/9, that is the same as 5 times 7 over 8 times 9. 5 times 7, 35. 8 times 9 is 72. Multiplying fractions is probably the most straightforward part of working with fractions. And it doesn't come up near enough, in my personal opinion, but I am sure that's not a common opinion. Because again, it's only bringing together pieces that multiply to get a final answer. Very simple indeed. So we have 7/8 times 3/10. 7 times 3 is 21. 8 times 10 is 80. Now at this juncture, I'm not reducing anything because based off what we know about numbers, these two do not have any factors in common, as both 7 and 3 are prime, and neither 8 nor 10 are divisible by 3 or 7. So this is the most reduced it can be. And so for 35/72 seconds, I can multiply a fraction, I just can't pronounce it. So as 5 and 7 are prime, nor 8 nor 9 are divisible by 5 or 7, so this is the most reduced fraction. Doing one more example for simplicity's sake. We have 5/7 times 3/4, where 5 and 3 are prime, neither of these are divisible, so our fraction, 5 times 3 is 15, 7 times 4 is 28, is as reduced as we can get. Now, having brought it up, we now come to an example where we may get something to multiply, such as 3/4 times 2/9, where 9 is divisible by 3 and 4 is divisible by 2, but we're going to multiply first before we reduce anything. So 3 times 2 is 6, 4 times 9 is 36, and it is this point we'll reduce. So 6 can actually go into 36 6 times. 6 can go into 6 once, so that reduces to 1/6. There is the concept. It's easier to do, but you have to be careful when you do it. So if we started over here and reduced before we multiplied, we have 3 times 2 over 4 times 9. And we know with multiplication, we can multiply in any order. So that's the same as 2 times 3 over 4 times 9, because we just simply swapped them. And then that still sits like 2 over 4 times 3 over 9. Each of these reduce in their own right. So 2 can fit into 2 once, 2 can fit into 4 twice, 3 can fit into 3 once, 3 can fit into 9 3 times. So that simplifies to 1/2 times 1/3, which 1 times 1 is 1, 2 times 3 is 6. Comes to the same answer of 1/6. This part may look longer, however, it feels more intuitive to make your small numbers smaller before getting anything but too big. Whichever way is easiest for you, please do so. But remember, this is a niche way to do it, in such that you have to be aware what parts are reducing. You can't reduce, let's say 3 and 2, we can't reduce on the top without reducing anything on the bottom. You will have changed the fraction, and you will have an incorrect answer when you're done. So, I have another example. 5 over 7 times 3 over 10. I'm going to reduce first. That is to say, 5 and 3 over 7 times 10. 5 and 10, they both have a 5 in common. 5 goes into 5 once, 5 goes into 10 twice. So 1 times 3 is 3. 7 times 2 is 14. And to show, just in case, that it does the same thing either way. 5 times 3 is 15. 7 times 10 is 70. They are both divisible by 5, or if you need to, prime factorization. 5 is 3 and 5. So then we have 7 times 10, which is 2 times 5. And the 5's cancel out, leaving the 3 over 14. Or if you wanted to start at this point, notice that they both are divisible by 5. 5 can go into 7 once. 5 can go into then 20 4 times. 5 can go into 15 3 times. So it all comes back to that 3/14. All right, so if we can multiply two fractions together, then we can multiply fractions times whole numbers. So we have an example 5/12 times 6. So that is having 5/12 of something 6 times. Now 6 is the same as 6 divided by 1. 6 divided by 1 is 6 ones. But for our usage, if it's written like this, you multiply the top number, so then you get 5 times 6 is 30 over 12. Because that 12 will multiply by 1 and it'll get you 12. Very straightforward. A lot easier than multiplying two fractions together, which is already pretty easy. And then from here, we see that something reduces. So let's see. They are both divisible by at least 3. So 30 divided by 3 is 10. 12 divided by 3 is 4. That again is divisible by 2. So 10 divided by 2 is 5. 4 divided by 2 is 2. So we're left with 5 halves, which, if need be, you can write, there we go, as the mixed fraction, because 2 can fit into 5 2 times, leaving a remainder of 1 as 2 1/2. That's 2 1/2. And then, have a further example. Well, thank you. We have 3/16 times 8. Now, just like with the previous fractions where we can kind of see and get a feel for something that could reduce, we know this 8 sits over a 1, and 8 and 16 can reduce because 8 can fit into 16 twice, 8 fits into 8 once. So now we multiply across. 3 and 1 is 3, and 2 and 1 is 2, which can reduce, or not reduce, you can rewrite it as a mixed number. So 2 can fit into 3 once, leaving a remainder of 1. We are given 4 times 5/7. So that is either taking 4 5/7 of something. Let's say we have this sphere, and we color in 5/7 of it, and we have 4 of them. Or we have 4 items, and we are taking about 5/7 of that. 5/7, 5/8, 4/8, 4/8. So that a little more than half, about the feel of it. Just to kind of give you a visual of what the feel is here. So we have this 4, sits over a 1. 4 and 5 is 20, all over 7. Rewriting it as a mixed number, 7 can fit into 20 not quite 3 times. So 2 So 20 minus 14 is 6/7. Or if you really, really wanted to, move it to a decimal. So 7 can fit into there twice. Minus 14 is 6. We put a decimal. All the decimals will line up. 7 can fit into 6 8 times. And that'll leave 4. And there's lovingly a whole lot of zeros to work with if you need more. As this gets smaller and smaller, the farther and farther you go. So 40, 35, so that's 48. So this drops to 2. Comes back around to 2. 2. So it'll start to repeat at this point. So this piece will repeat. We put a bar over it to say, hey, this repeats. We don't have to keep writing that over and over and over and over again. Because once we get to that 20, it's like this 20. We got the 14, we'll bring that 6. If we have the 6, we'll bring that 5. And so we will just repeat forevers and evers. You're welcome to try this. It's a wonderful exercise. You don't have to, but you're welcome to. Right. So, because we can multiply by whole numbers, and because we can multiply by fractions, we can now multiply by mixed numbers. So if we have 1 1/2 times 3/4, the best and easiest way I can recommend is to change this into a mixed fraction first. Or an improper fraction. I'm sorry, this is a mixed number. So how we did that, we multiply the whole bit by the denominator and added it to the numerator. So 1 times 2 is 2. 2 plus 1 is 3. So that is the same as 3/2. And we have done this previous, so we know we've done it both ways. So we have 3/2 times 3/4. Multiply across, 3 and 3 is 9. 2 and 4 is 8. And you may rewrite this as a mixed number, 9/8. 8 can fit into 9 once, leaving a remainder of 1. We have another example of 5/8 times 3 and 1/2. Now we have 2 1/2, which is 5/2. So 3 1/2 will be what? So we have the 5/8 times the 3 times the 2. 6 plus 1 is 7/8. And then we multiply across. So 5 and 7 is 35. 8 and 8 is 64. And because 35 is smaller than 64, that does not have to be rewritten as a mixed number. And because we can now multiply fractions by mixed numbers, we can multiply two mixed numbers. 3 and 2/3 times 2 and 1/2. So we must first rewrite each of these. So 3 times 3 is 9, 10, 11. L over 3. 2 times 2 is 4, plus 1 is 5. And now we can multiply straight across. 11 times 5 is 55. 3 times 2 is 6, which can be rewritten as the mixed number, 5 fitting into 55 9 times, which is 54. 55 minus 54 is 1. We have a remainder of 1, so that is 9 and 1/6. Yeah. Alrighty. One moment, I'm fetching paper. All right. So another example is, I think we just did that one. Hold on. 3 2/3. No, that was. Okay. So I'm given a note here saying how there's the mistake in an example that 3, let's say we go back to the 3 and that 2/3 times 2 and the 1/2. This is not the same as 3 times 2 plus 2/3 times 1/2. This is not the same. But if you want to get real technical of why, well, and we will get real technical as to why, so hold off on that example. I'm going to show you why that this is not true. Because although we do have 3 plus 2/3 to get you 3 and 2/3 times 2 and 1/2, which is 2 plus 1/2. And multiplication is distributive. So what this means is that each of these numbers can multiply each of these numbers. Later on, you'll find we have FOIL in these cases when we have the sum of two things multiply the sum of two things. This is the multiply the first, outer, inner, and last. Just so you make sure you get all pieces that are being multiplied. So this is going to be a kind of proof to show you that this and this are not the same. Because this is exactly what we're given, and this is a grotesque misrepresentation of what we were given. So first, outer, inner, last. Now the school I grew up in, we had FOIL, but we also had what was called monkey face because of how you multiplied it out. It's really up to you, whichever you want to call it. The function is the same. So first, we have 3 times 2 is 6. Outer, so 3 times a half, as we know, is 3 halves. We're not going to worry about reducing that just yet. We'll come back to that. And then we have 2/3 times 2, so that is 4/3. And last would be 2/3 times 1/2, so 2 times 1. That would be my colleague, I'm sorry. So then 2/3 times 1/2 is 2/6. And now you can sum all those pieces together. 6 plus 3 halves plus 4/3 plus 2/6. Now we haven't gotten quite into how to add fractions yet, so please bear with me as I make a jump to get a common denominator to be able to add them together. So we'll have this 6. So 36 over 6. Plus 9 over 6. Plus 8 over 6. Plus 2 over 6. So 36 plus 9 is 45 plus 8 is 53 plus 2 is 55. Lo and behold, that's what we were given when we multiplied them together. And that reduces, or that can be rewritten as 9 and 1/6. Mixed number. Now what we have done here is incorrect. Because you get your 6, your 3 times 2 is 6, plus 2, 6, which is not equal to 9 and 1/6. So no, do not do this. Please do not do this. I will not sleep ever again if he did that. That'd be so sad. This is wrong. This is so wrong. If you must break it up into a sum and then multiplication, you are allowed to do this. Don't do that. Okay. I have ranted for today, so that should do it. All right. So let me get into the next example. So we'll give another example, 2 1/3 times 3 1/2. Changing these both into improper fractions, 2 and 3 is 6 plus 1 is 7, times 3 times 2 is 6 plus 1 is 7, but this is over 2 and this is over 3. 7 times 7 is 49, and 3 times 2 is 6. And it can be rewritten as 6 times 8 is 48. 48 from 49 is 1. So it'd be 8 1/6. All right. So given the next example, we have 3 1/3 times 2 2/5. Going to then change to improper fraction, reduce, and then multiply. So 3 and 3 is 9, plus 1 is 10. We keep that 3. 2 times 5 is 10, plus 2 is 12, over 5. And we can see right away there's things to reduce, the 10 and 5. 5 can fit into 10 twice. 5 can fit into 5 once. 3 can fit into 12 4 times. Yes, 4 times. 3 can fit into 3 once. And now we can multiply across. 2 and 4 is 8. Over 1 times 1 is 1. And that's just 8. Well, isn't that lovely? Sometimes math be nice. Right. Have another example of 2 2/3 and 2 1/4. 2 and 3 is 6, plus 2 is 8. 2 and 4 is 8, and 1 is 9. And again, we can see that things can reduce. So 4 can fit into 8 twice, 4 can fit into 4 once. 3 into 9 3 times, 3 into 3 once. 2 times 3 is 6. 1 times 1 is 1. And that's just 6. And as I do more math in my life, I get more and more suspicious when numbers come out too nice. I know it's a nice thing when they do, but I get the feeling something had to have gone so wrong to be that right sometimes. So this is nice, but I'm suspicious. And we will learn in the next time how to divide so we can verify these suspicions, if they're true or not. I have one more lovely example, because if you can multiply two numbers, you certainly can multiply 3. So we were given 5/8 times 4 4/5 and 1/6. I'm going to do this in 2 ways. I'm going to multiply the first 2 and then the next one. And then the other way is multiplying the last 2 and then the first. So multiplying these 2, we get 4. We have to rewrite this first. So we have 5/8 times 4 times 5 is 20, plus 4 is 24, over the 5. We can reduce this. 8 into 24, that's 3 and 1. 5 and 5 is 1 and 1. And multiply across, that is 3 over 1. I'm going to go ahead and keep that 1, as we have another thing to multiply. So 3 and 6 reduce. 3 can fit into 3 once. 3 can fit into 6 twice. So that leaves us with 1 over 2 as 1/2. Not too shabby. Not too shabby. And now the other way. So we're going to have 4 and 4/5, which is 24 over 5. Same way, either way. Same thing, either way. And 1/6. Well, then the 24 and 6 can reduce into 6 can fit into 6 once. 6 can fit into 24 4 times. So 4 and 1 is 4, and 5 and 1 is 5. So then we have that 5/8 times the 4/5, where 5 and 5, 1, and 4 can fit into 8 twice, and 4 once, leaving us with that 1/2. Easy peasy. See, it's not so bad. All right. Going into examples, we have 54 examples, and I think we can get by with doing every third problem. Starting with number 1. And number 1 through 15 say multiply. Be sure to write each answer in simplest form. Now, the phrase simplest form seems a bit subjective to me, but I'm sure what they mean is that if you have an improper fraction, rewrite it as a mixed number instead of leaving it as an improper fraction. I know a lot of mathematicians who would just leave it as an improper fraction because it's easier to work with later on. But in layman's terms, it is nicer to see a whole number and a fraction rather than an improper fraction was like, well, what does that even look like kind of feeling. So in this context, we're going to assume simplest form means mixed number, not improper fraction. So then we have 3/4 times 5/11. Nothing can reduce, so we simply multiply across. 3 and 5 is 15, and 4 and 11 is 44. 4, we are given 2/5 times 3/7. Nothing reduces. 2 times 3 is 6. 5 times 7 is 35. 7, we have 6/13 times 4/9. Now 6 and 9 both have a 3 in common. 3 can fit into 6 twice. 3 can fit into 9 3 times. 13 and 4 have nothing in common. We have to leave those as is. So 2 times 4 is 8. 13 times 3 is 39. And if you must, instead of reducing, if you have to, if you feel like, if you didn't see it, you could have multiplied straight across. So you could have had that 6 and 4, which would have been 24. And 13 and 9 would have been 90 plus 27 would be 117. Which in this case, both would have a 3 to fit in there. 3 can fit into 24 8 times. And 3 can fit into 117 39 times. So it would eventually reduce. Well, you can see that it's divisible by 3. If you add 1 plus 1 is 2. 2 plus 7 is 9. 9 is divisible by 3, so 117 is divisible by 3. If you'll remember from our previous episode. We have 7 ninths times 3 fifths. Got that 3 and 9 again. So 3 can fit into 3 once, 3 can fit into 9 3 times. So 7 and 1 is 7, 3 and 5 is 15. We have 7 ninths times 6 fifths. The 6 and 9 both have a 3 in common. It is a 3 and a 2 respectively. 7 times 2 is 14. 3 and 5 is 15. I'd like to note that each of these are already in proper fractions, so we did not have to rewrite anything. We have 13, 16. So then we have 3 1/3 times 9 elevenths. So first we rewrite. 3 and 3 is 9, plus 1 is 10, over 3 times 9 over 11. 3 and 9 reduce. Leaving 3 times 10 is 30. 1 and 11 is 11. And this can be rewritten as 2. And 30 minus 22 is 8. Remainder of 8. Yes. So then we have to rewrite. 3 and 4 is 12, plus 1 is 13, over 4. The 4 and 2 have a 2 in common. 1 times 13 is 13. 5 times 2 is 10. This can be rewritten as 1 and 3/10. Like so. 18, 22. We are given 3/7 times 14. 14 we know is 14 over 1. 14 and 7 have a 7 in common. So 3 times 2 is 6. 1 times 1 is 1. So that is just the whole number 6. So we were given 12 25ths times 11 18ths. The 12 and 18 both have they have a 6 in common. 6 can fit into 12 twice. 6 can fit into 18 3 times. Nothing between the 11 and 25. So we have 2 times 11 is 22. 3 times 25 is 3/4, which is 75 cents. And that does not need a mixed number. It is good as is. We are given 21 25ths times 30 sevenths. It can reduce in several spots. So the 21 and 7 have a 7 in common. 7 can fit into 7 once, 7 can fit into 21 3 times. 25 and 30 have a 5 in common. 5 can fit into 25 5 times, into 30 6 times. So we have that 3 and the 6, which is 18. 5 times the 1 is 5. This can be rewritten. Let's see, 15, so that is 3 times 5. And then 18 minus 15 is 3. So 3 and 3/5. And 31. To multiply, we must rewrite. So 3 and 5 is 15, plus 3 is 18. Excuse me. 4 ninths. The 9 and 18 both have a 9 in common. So 4 times 2 is 8. 1 times 5 is 5. 5 can fit into 8 once, with 3 remainder. Okay. So we have 1/3 times 1 and 1/5. We must rewrite each of these. 1 and 3 is 3. 3 plus 1 is 4. 4/3 times 1 times 5 is 5, plus 1 is 6. All over 5. So the 3 and 6 can reduce. 1 and 2 respectively. 4 and 2 is 8. 1 and 5 is 5. 5 can fit into there once with 3 remainder. Looks familiar. All right, so we are provided now with 4 1/5 times 10 and 21ths and 9 20ths. First to rewrite, and we're going to simply work left to right, because as we read, and it doesn't really matter which order we take this, left to right is more intuitive than picking and choosing. At least in English. 4 and 5 is 20. 21 over 5 times 10 over 21 times 9 over 20. Well, I say that whatever can reduce, we will try to reduce. We have these 21s. If they're in the top and the bottom, they both fit, and they're lovely. So then we can pick this 5 and this 10. 5 can fit into 5 once, 5 can fit into 10 twice. But then we have this 2, and 2 and 20 can reduce. 2 can fit into 20 10 times. 2 can fit into 2 once. And that leaves a bunch of 1s, which is super nice when multiplying. 1 times 1 times 9 is 9. 1 times 1 times 10 is 10. Well, it's much easier than I anticipated. Right, and then 40. We have 4 1/2. Alright, I do see something about these 5s and that 15. Not to reduce now. Now would be too soon because we have other pieces that need to be rewritten before we can reduce. Rewrite before reduce. Kind of like how you have to eat before you use the bathroom. So, to rewrite before you reduce. Huh? Yep. 35 over 6 and 8/15. So, as we can rewrite, it was just easier. 9 and 6 both have a 3 in common. So that's a 3 and a 2. And this 3 and the 15 have that in common. So 1 and 5. This 35 and 5. That's a 7 and 1. And this 2 and this 8. And this 2 and that 4. Golly gee, it reduces everywhere. So we have 1. On the top, we have a 1 times a 7 times a 2. So that's 14 over 1 times a 1 times a 1. So 1. So that is 14. right. We have another problem. It's 43. 3 and 1/5 times 4, and 2/3. 15, 16 over 5, 12, 13, 14 over 3. I don't see any reductions here. So I know the bottom is 5 times 3 is 15. Because I need to, I'm going to write it over here. So it's 160 and 40 and 24. So 4 carried 1, 2, 24. Because nothing can reduce here, nothing will be able to reduce here, other than rewriting it as a mixed number. So then 15, 224. Personally, I know that 15 squared is 225. So that means 15 can only fit into here 14 times. So then 15 times 14 is 150 plus 40 plus 20. Because 10 times 50 is 150. 4 times 10 is 40. 4 times 5 is 20. 5, 9, 10, 11. And 14/15. Oh, 43, 46. Yeah. We have 3, 4, 5, 5, 6, 7. Rewrite. So 15, 19 times 35, 41. Nothing reduces. Oh, golly gee, nothing reduces. So then we have this 5 and 7, which is 35, 19 and 41, where 10 times 41 is 410. 9 and 4 is 36. And then 9 times 1 is 9. So 9, 7, 7. And despite there being a lot of 7s in this number, it is not divisible by 7. Or else it would have reduced previously. So 779 divided by 35, because that is essentially what we are given. So 35 can fit into 77 twice. It can fit into 79 twice, with a remainder of 9. So the mixed number here is 22 and 9, 35. All right. 46, 47, no, excuse me, 49. And you can use your calculator to verify these last problems, as they are supposed to be calculator exercises. But because of the necessity of rigorous mathematical work, we are going to do them by hand, so you are very familiar with multiplying with fractions going forward. So we have 7/12 times 36 63rds. You can see that 36 and 12 have a 12 in common. 1 and 3. 7 and 63 have a 7 in common. And 3 and 9 have 3 in common. So that leaves a 1 times a 1 is a 1, and 1 times a 3 is a 3. And some things that look formidable are actually quite easy when attempted. They're supposed to be scary. It weeds out the weak. And then we have 18 over 132 times 36 over 63. Now, I'm going to go ahead and reduce on this side first. You don't have to reduce across, as this has a 3. 18 from 3. 6. And 3 can fit into here 44 times. And 6 and 44 have 2, so that's a 3. And 22. 36 and 63 both have a 9 involved, so that's a 4 and 7. Nothing, this 4 and 22 can reduce. That's a 2 and an 11. Nothing else can reduce, so we've done all we could. 3 times 2 is 6. 11 times 7 is 77. All right, and we will do one more for funsies. Any questions, comments, concerns? Please let me know. Okay. So 1 plus 5 is 6, plus 3. Oh, that's 9, so that's divisible by 3. Well, actually, that's 9, which is divisible by 9. So these two have a 9 in common. 9 times 9 is 81. 135 divided by 9. 9 can fit into 13 once. 9 can fit into 45 5 times. And it can reduce again. So we have 3 can fit into both. 3 can fit into 5 times. I think that's all we can do with those. These two have at least a 2 involved. So 2 can fit into here. 12, 68. And that is 42. Can be divided again by 2. It's 34 and 21. I think that's all we can do. I don't think 34 reduces with anything else. Well, we get what we get, which is less than what we were given. 3 times 21 is 63. And 5 times 34 is 150 plus 20, which is 170. I get the feeling that reduces. Just to check, 34 is 2. That's 15 and 17. So no, that's all that can do. Yep, that's the best we got. Alrighty. That covers multiplying fractions. So the next thing are applications of multiplying fractions. I think we will skip the applications. No, actually, it has to do with labeling. Labeling your multiplication of fractions is very, very important. We will so totally go over that, because if you have 60 minutes in an hour, and you have 24 hours in a day, how many minutes do you have in a day? We'll give you minutes per day. And then we'll have to reduce from there. Not only do we multiply the numbers, but we also multiply the words, which is pretty cool. Thank you for all the support. That's so nice. Let me know if you have any questions, either now or later. I will try to keep up with all the comments going forward. I know I will be here this Thursday, the 27th, for a video. And next week, Tuesday and Thursday, for videos. But I will keep you posted if there will be anything further. In that case, there's nothing left to do but have a good day.